In case anyone's new here, I'm a solo indie game developer currently working on a sci-fi cooking competition show game called Galactic Chef. In this series, I'm going to talk about the more technical details of the systems behind the game, starting with procedurally generated ingredients, which are a huge part of the game's replay value. In this video, I'll be making a new ingredient template from scratch and talking about how that template is translated into an actual ingredient on the rack. To keep things relatively simple, the procedural generation is based off of handmade templates, starting with pixel art that allows me to arrange up to 3 subcomponents of each ingredient, using red, green, and blue. In this particular ingredient, I'm going to have a poisonous pit represented by the blue component. So I've just completed a first layer, which will be the center cross-section of the ingredient. I'm now going to add some extra layers to give this ingredient some depth. I'll make the other layer semi-transparent so I can tell what I've actually added in this pass. And I'll put one more layer on top. Now that I have my layers, I'm going to make them fully opaque again and export them individually. Now the other half of an ingredient template is a definition file. Here I've got the egg template on the left for reference. After identifying a version, in each template I have a list of possible names I've come up with myself to avoid having to blacklist every offensive thing that might come up when just smashing letters together at random. Next I specify the pixel art layers I just created, repeating 2 of the layers because this ingredient will be symmetrical from front to back. Now it's time to define the individual components. Similar to the egg, I'll have the opacity of the shell range from 0.7 to 1. And I think I'll actually just copy this list of possible mouthfeels to start with. These are all the possible textures that the shell could have before you do anything to it, but that texture can change depending on what you do to the ingredient. Now, these ingredients are fictitious and alien, so I can't just make everything up as I go. Now, I'm going to consult my list of possible mouthfeels for this one. I'm going to make this interior substance be potentially soft, fluffy, chewy, or tough. That sounds about right. Now, you might notice in the egg template I have this raw attribute set to very common. That means that 99 times out of 100, the goop in the egg will be raw and need to be cooked. I have a bunch of presets like this for different probabilities, but I don't think I want any of this particular ingredient to be raw. However, I do want to make the pit always toxic. And that's all I have to do to add a new ingredient template. Now let's look at this new ingredient in action. Looks like I've got 2 instances of it in this particular show. And I haven't shown this magnified laser board yet, but it'll help us take a closer look at the ingredient. If I slice it in just the right place, hopefully we can see the poisonous pit inside. You can tell that it's a little bit different color, but it doesn't stand out too much. Let's take a look at this other one. Once again, it's not a very obvious color difference, so I might go back and add a way to ensure higher contrast between components, but for now that'll do. Let's take a look at the C++ code. Now, I'm sure some of you will find things that I could have done better here. For indie games, it often seems better to choose the quick and dirty solution and not worry about optimization until you know where the actual bottlenecks are. And as a solo dev, I admit I take a lot of shortcuts. But currently this is all pretty fast and it only happens at the beginning of the game, so it doesn't slow anything down once you get started. So if it isn't broken, why fix it? So here I'm getting all the ingredient templates and just randomizing the order. Then I use the ingredient template class to encapsulate the information from that definition file, and I'll be taking a closer look at that process in a moment. I then cycle through all the templates, creating 1 ingredient from each, and removing any template where I've exhausted all the names in my list. This useTemplate function is what actually applies the template to the new ingredient. Once I'm done, I randomize the order and modify some of the ingredients to ensure that every flavor in the game is represented by at least one of them. I'll take a closer look at forced primary flavor later as well. Finally, I randomize the list one more time just so you don't see all those forced flavor ingredients in any predictable order. Let's take a look at that ingredient template constructor next. I start by reading in the file and splitting it by lines. If we look back at the file, you'll see that I have the type of information on that line, followed by a colon, followed by either 1 or potentially a list of values. So my next step for each line is to split by the colon. The part before that is the type of information on the line, and the rest is split by commas. Each comma separated value is stripped, and now that I actually have inconsistent capitalization, I'm going to add a to lower here. So the rest of the interpretation depends on what type of information the line holds. The version check, suffix, and names are all pretty straightforward. The list of layers remains a list of strings for now, but I'll be doing more with that later. For each component line, I create an instance of another struct. A lot of things aren't decided until the template is actually used, so I need to keep the range of opacity, all the possible starting feels, and the probability settings for features like raw, toxic, dirty, or whether or not a substance melts. This roll feature function will convert things like very common to a yes or no, when a specific ingredient is actually being generated. And for reference, this is what the ingredient template looks like. So back to that template constructor, lines like opacity and feels store the relevant data on the most recently created component specs. For all the probability-based features like raw, melting, etc., I'm just converting the string in the file to an enum value. And that's it for this constructor. Now when it comes to actually using the template, I start by assembling the ingredient name. For each layer I need to actually read the image data, and I'm keeping account of how much there is of each component substance, because I'll need that for forcing the primary flavors. Back to use template, for each component I'm going to make some decisions, starting with choosing the actual starting mouthfeel from a list. Texture generation is a bit complicated, and I've covered that in another video already. But basically, I choose a starting texture at random, and then convert the red, green, and blue channels into amounts to use of 3 randomly generated colors. This allows me to have smooth and textured blends between different colors that can vary wildly from ingredient to ingredient, but also from component to component. Back to use template. This is where I start deciding which of those probability-based features actually get applied. If the ingredient is raw, I add some heat-based reactions to first remove the raw attribute, which does cause some other changes, and then also add a burn reaction so you can't leave it on high heat for too long. The burn reaction is delayed enough to make sure that you can safely cook the food before it starts to burn. Although currently burning only happens on the highest temperature, so I intend to add an overcooking reaction, so there will be consequences for leaving the food on the heat too long, even at medium. This might apply to low heat in the future too. I have similar functions for adding other types of reactions. The melt reaction, for instance, changes the texture of the food, heavily biasing it toward a liquid, although technically melting isn't guaranteed. I also add a complementary reaction so that melted components can re-solidify. Most of the other reaction creating functions are pretty simple. The toxic feature I'm using in my new ingredient template doesn't even add any reactions. The idea here is the component is permanently bad and needs to be removed from the food to make it safe to eat, which you can do by cutting it off with the laser board. The final piece worth noting here is exotic ingredients. If an ingredient is chosen to be exotic, it'll forego the normal reactions that apply to almost everything, and instead add a bunch of complete randomness, starting with a random number of reactions to generate, random type, length, and even a variable number of effects. Specifically, these can be flavor, texture, or color changes. Now let's take a look at how I ensure there's at least one ingredient with each primary flavor. I start by deciding whether or not I can use one component to achieve the desired effect, by figuring out the total number of particles, or voxels, and what the largest subcomponent is. If that largest subcomponent is a large enough portion for it to dominate the flavor of the entire ingredient, then that's the only one I need to modify. But if not, I'll make changes to all of the components. Depending on which, I'll determine a minimum strength for the forced flavor, and then randomly choose a value between there and 100%. Then I just override the strength of the desired flavor, and make sure everything else is less. And that's it for ingredient generation. So what do you think of the new video format? Was it too much detail, not enough? Anything you'd like to see me do differently, or any topic you want to see me cover next time? Let me know if you have any feedback in the comments, and as always, it helps me out if you hit the like button, spread the word, and subscribe if you haven't already. And of course, thanks for watching.